Recording is in progress. Welcome to our class today, May 17th, 2022. Good morning to everybody. I believe you just received an announcement regarding the Google Sheet. I will share my screen for you in order to explain how we will deal with this sheet. Just give me a sec. Can you see my Google Sheet? Yes, no. Okay, thank you, Yunka. So here is our Google Sheet. If you see, we have two sheets, individual and the group. For example, here group 1, we said for the optimal is 5 for each group. If you are only 4, then we can add one of the individual later. In certain circumstances, I would accept 6. So if you are 6, just add your names there and email me and give me a valid reason why you are 6. But if you are 6, most probably it would be accepted. However, I would expect like some extra or more equality than a group of 4 or a group of 5, to be fair. So add your name there, and for those like first group, then the second group, like add just group number 2, 1, 2, 3, 4, 5, however the number, then number 3, group number 3, group number 4, group number 5, and that's it. If you are individual, you don't know anybody, and or you like wasn't successful to join a group, just add your name here. Either we will form a group later of those, or if there are groups of 4s, we can add one member after consulting with them. Any question about how to add your name to a group? Is this clear? The deadline is the beginning of the class next Tuesday. We need to finalize the group project to assign topics. Then I will make the course plan with when the first report is due, when are the presentation, when is our final exam, so we can put a like an estimated project plan so we can stick with it. Is that clear, guys? Questions? And you can feel free from now, you can add your name if you agreed to be a group. Questions? Or for example, if you find a group of 3 and you would like to join with them, you can email them, ask them, can I join the group? Then you can add your name. This is another solution because some of you maybe they don't know each other. For the topics, we'll talk about it next week once the group are finalized. Okay, guys? Okay, so I know in the course outlines we mentioned that the revision of probability would be before linear algebra. However, I find that to start with linear algebra, then probability next week, and optimization, that would be like more appropriate. However, those are concepts you should know about it since you are a graduate student in engineering. It's just a reminder. I will not go in deep explaining everything. If you find yourself that you need to dig more, you know, the YouTube, the net is full of resources. I can put like an extra materials, like few presentation about linear algebra topic and probability topic, because, you know, it's a kind of revision. And I hope that today's class will not take too long. And if you find, but what I want from you guys to study to make, yeah, for sure, for sure. If you are 4 and you don't want to have anyone more, that is okay, no worries. You are welcome. So I like just go very quick over the linear algebra. If you need more explanation on linear algebra, I will add some resources, some videos. Just send me an email that I need something about this, then I can share with the class like a video and a simple presentation. So it's kind of revision. I would assume that when you enter the course that you have the background of linear algebra, probability optimization. But if not, or you forget, it was a long time ago, we try to remind you and give you the resources to revise these things. Is that clear, guys? Okay, Aisha. Thank you. Ankon, thank you. So I will start. I uploaded today. I uploaded the linear algebra one. Let me share screen. Can you see the slides? Okay. Thank you, Ankon. Thank you, Aisha. Okay, so today it's a linear algebra review. As you see, it's 109 slides. We'll go very quick over them. It's just a kind of like refreshing your previous knowledge in linear algebra. If you find any topic, I have a separate presentation for each topic in linear algebra. Also, I can search the YouTube, or you can search the YouTube. If I find a very nice one, if you send me an email, then I can share it as extra resources. It's not part of our material, but as you know, when we discuss, and today, so today also in this presentation, we'll discuss some concepts from the last chapter when we say introduction about a neural network. So today we will use a neural network example. So I need, as I told you, our example would be an engineering example and related to our course. So we will use the linear algebra, some concepts of linear algebra, why we need linear algebra in machine learning, using machine learning technique like neural networks. So the outline, we'll talk about matrix arithmetic, matrix properties, some example on a blackboard. Those would be an extra resources. Then recap additional matrix properties, SVD. We'll talk about those, all of those in a quick, like on the surface. If you want to go deep, it would be you are a graduate student. And as I mentioned before, you should have a knowledge or a prior knowledge about this, but just to let you know what you are going to need when you study machine learning techniques. So matrix arithmetic, and this would be with application to neural networks. So for example, start with the simplest operation in the matrices. Assume we have matrix E and B, and I ask you to find the summation of these two matrices. I'll not go like for the abstract information, what is the dimension of the matrices to do the addition. Those are things high school level. So for example, we add like the first element in the first row with the first column with the same in the second one. So 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. Then the summation of the first two matrices will end up with 6, 8, and 12 new matrices. Sometimes we need a scalar in data pre-processing, we need sometimes a scalar. Sometimes you save your data, especially if you are using MATLAB, you will save your data as a matrix. How we'll do the scalar? If we have the vector x, if we have a vector x, then we need to do a scalar to that vector x. Then we multiply it with an a, like a certain number or a certain scale with vector x, then vector x become bigger and at larger scale. Then, for example, like this one, if we have a and a vector x consists from x1 to xn, and we multiply it by a, then the new vector, the scaled one, would be ax1, ax2, and where a is any scale or a numeric scale that we choose. Okay, now to find the product of two vectors or the multiplication, we have three waves. I'll go in very quick over them. We have three ways to multiply matrices or vectors: element by element, inner product, and outer product. So element by element, and this is element-wise multiplication in MATLAB, for example. So if I have a1, a2 multiplied dot or star, doesn't matter, or without any dot or star, or just we have the first matrices and the second matrices immediately without any symbol between them, it also means the product. Then I'll have the first with the first, the second with the second, since they have the same dimension. Dot product, or what we call it inner product, if we have the vector x with the product of vector x and y, the inner product. So if we have x1, x2 to xn times y1 to yn, even if this is one row, and you know there is a rule for multiplication that the number of rows should equal the number of columns in the second one, or the number of columns should equal the number of rows. These rules, you need it in different stages. You have to know them. So then this will be x1, y1, x2, y2 to xn, yn, and this would be the summation of this. Or it is the sigma. It is the sigma from I1 to n for xi, yi. So we'll have one number, which is the inner product for the whole matrix. And you know here in MATLAB, it's 1 times n. We have one row with n columns, and here we have n rows with 1 columns. So the outer dimension gives size resulting in matrices 1 by 1. These are the rules I'm talking about. You should know them. Okay, for example, dot product for geometric intuition, overlap of two vectors. So if we need this, it would be the length of x, the vector x, times the length of x vector y, times the cosine of theta, which is the how much theta between x and y. So now we'll start talking about a neural network. Till here, any question? I think you know this information before, right? And everyone took linear algebra in the undergrad. Whatever you are, a computer science, whatever you are, a software engineering or electrical, mechanical, you should talk. It's one of the mandatory courses for any engineering topic or a science topic, linear algebra. So, example. If we have a linear feed forward neural network, because you know neural network, we have feed forward, feed backward, back propagation. We have multiple techniques for a neural network. We'll talk about them end of the term. But what is the concept of a neural network? that I will have from 1 to n neurons. We are simulating the neural network inside the human body. So we have input as in neurons. We have, for example, from neuron 1 to neuron n. Then we will add the weights. Then we will receive the output. So this will be multiplied by weights, same as this example. You see? So we'll find these are the weights. We'll take the multiplication, then we will R1. So we will receive that the first neuron with the weight times the weight, the second neuron times the weight, to the last neuron times the weight, and all of them will produce one by one, which means one value, and this will be the output neurons firing rate. And this is one layer neural network. This is one layer neural network. At the same, if we simulate this with a vector R for the neurons, with the vector W for the weight, then it will be the product of R times W, then all of them times the cosine of the theta, which is how much we have the angle between R and W. So inside, for a given input L2 magnitude, the response is maximized when the input is parallel to the weight vector. Receptive fields also can be thought of this way. So if they are parallel, then we will consider the times of weight, and then we will maximize it. If you ask me how if R and W are parallel. Multiplication, outer product, what we call it outer product, which means that it will produce a new matrix with the new values. So if I have n times 1, if I have a matrices, multiple rows, n rows with one column times one row with m columns, then it will be result in n times m as dimension of the new matrices. How this will be x1, y1, then x1, y2, x1, y3 to ym. Then we will start with the second one, and we will form the second row till we finalize the last element of the first matrices with the last element here with y1 to ym each time. Then we'll find this matrices as what we call it outer product. So inner product will result with one value. Outer product will result in multidimensional matrices. And the first product we see here, if you remember this one, so it will result in like one matrices with the same dimension. So these are the three types of, or the three ways to multiply matrices. Clear? Questions still here? You see here, even if you go with that, it's interactive slides, you will see this one will form the first element, then this one with x1 will form the second element, then the very last one with the first element, then we'll go here, then we'll go here. So note, each column or each row is a multiple of the others. So if we have a matrix time a vector, because you know the vector, it's one dimension. So if we have a matrix and we need to multiply it by a vector, how this happen? Question still here. Clear, guys? Are you with me with the same page? Yes, no? Thank you. So here, if I have y, which is resulted from the multiplication between a matrix and a vector, we have a matrix W and a vector X, so it will result in y1 to ym. Is that clear? Okay. So we have m times n times 1, then it will end, if we took the n and n, it will end with a result of m times 1, which is multi-rows with single column matrices or vector. Okay, inner product interpretation. So what is the rule here? The ith element of y is the dot product of the ith row of w with x, with given x. So you see, then y2, y3, till we end with this one. Here we have w, we'll take w as vector 1. We do it with x, then we'll go to the next one, till we find y. So it's x1 with the first column of w, then x2 with the second column, xn with the last column, then it will end with y. So these are example of outer product. So this is a vector and this is a matrices. How it will be, it's 2 times the first column, 1 times the second column, and it will end with 0, 4, plus 3, 1, and it will be 3, 5. Is that clear, guys? So the dot product between this vector and this vector, it will be this vector. Is that clear? No different combination of the column of M can give you any vector in the plane. We say the column of M span the plane. Rank of a matrix. Are there special matrices whose column don't span the full plane? Yes. You can only get vector along the 1, 2 direction, output live in 1 dimension, so we call the matrix rank 1. So we don't talk the negative direction. If we have two layer of a neural network, how this would be, it would be the x with weights will result in y, then the next step will have y with the new weights will result in a new one or with a new value. So wij is the connection strength weight onto neuron yi from a neuron xj. So neuron y1, it is the w of I and j times xj. So the inner product for two layers, what is the response of cell yi of the second layer? So it will be yi from j equal 1 to n for wij xj. The response is the dot product. Be careful, it's the product of the ith row of w with the vector x. So continue. So this is the first column of w. With this operation, we'll get the contribution of xj to network output here. Then we'll have a, b, and equal c. If we have n times p with p times n, then we'll have n times m. In MATLAB, we call it inner matrix dimension must agree. So pp should be there in MATLAB. Note, matrix multiplication doesn't generally commute a. The dot product of AB should not be equal B plus A, BA. Matrices by inner products. So say ij is the inner product of the ith row with the jth column. Like this. Ith row with the jth column, we'll find this one. Or Cij, it's equal the summation from k equal 1 to p for a, ik, b, kj. So here we'll take ac1, whatever the number of row, plus AC2 to the power BR2, here BR1, then ACP to the power PRP, and we'll find C is the sum outer product of the column of A with the rows of B. So these are how we do the summation or the product of two matrices, the three ways. Questions still here? I'm sure that you need to revise yourself, solve some examples, but this is a review chapter. This is a review chapter. Matrix properties. So special matrices, diagonal matrix. One of the special matrices that we have, that the diagonal matrix. So we have values on the diagonal, and in the top of the diagonal and the bottom of the diagonal, we have zeros. This acts like scalar multiplication. These matrices will act as a scalar multiplication. So if we have a scalar, then the matrix D times the vector X will have D1, X1, D2, X2 to Dn, Xn. So we can represent this as a vector or a scalar vector. Identity matrices, then if we have all ones and all other in the diagonal and all other zeros, so for all matrices A, 1 times A equal A times 1 and equal A. And it's a vector 1. Inverse matrices, what do we mean by inverse matrices? Which is the, and we represent it by the A to the power -1. So if we have 0, 1, 0, 1, and 1, 0, and we have M, which is 0, 3, 2, 1. Here, how we'll do this? So the determinant of M, so it's determinant of A, B, C, D, which is AD minus BC. AD minus BC. AD minus BC. This is the determinant. Solve the algebraic equation. So it is the matrix A minus lambda with the identity matrix, and times the X vector equals 0. So determinant is 0 or X equals 0. So this is the solution for this one. Another example of underdetermined system. So I have 1, 2, minus 1, minus 2 times x1, x2 equals 0, 0. So this one will be x1 minus x2 equals 0. Then 2x1, 2x1 minus 2x2 equals 0. These are the equation. Then I can solve it. Well, and you can revise the lesson which say solving equation using matrices. Then here we'll end up that x1 equal x2. Some non-zero x are sent to 0. The set of all x with mx equals 0 are called the null space of M. This is because determinant of M equals 0, so M is not invertible. If determinant isn't 0, the only solution is x equals 0. Here, what do matrices do to the vectors? If I have this matrix and I have this vector, what it will do? This is the matrix and I have this vector. So it will be 2 with the first row, then 1 with the second column, first column, then 1 with the second column, and we'll end 0 and 4 plus 3 and 1, which is 3 and 5. So let's do a scalar. So the new vector is rotated, scaled. Are there any special vector that only get scaled? So if we have 0, 3, 2, 1 with 1, 1, try 1, 1. So x equal 1, 1, then we'll end with a 3, 3. So it's scaled also. For this special vector, multiplying by M is like multiplying by a scalar. 1, 1 is called an eigenvector of M. 3, the scaling factor is called eigenvalue associated with this eigenvector. So these are the names that we are talking. Are there any other eigenvector? Yes. The easiest way to find is with MATLAB egg command. So if we have exponent to the power with egg vector to 1, 1, 1, and exponent to 1, exercise verify that minus 1.5 and 1 is also an eigenvector of M. This is what we call it in class practices. I'm waiting your solution next week. Note, eigenvector are only defined up to a scale factor. Conventions are either to make ease unit vector or make one of the elements 1. So this question in slide 82, it's in class practice. You should submit it by next week. Okay, I will share another Google Drive to submit there. Clear? Eigenvector obey this equation. You can read this example on Blackboard. We don't have a Blackboard to do example. As of next class, I will start using the touchpad. It's in the way. I believe I will receive it tomorrow, so I can put notes using like pen, same as I'm explaining in board. So you have to recap also additional useful stuff like matrix diagonalization, recap, transforming between original and eigenvector coordinates, more special matrices and matrices, then singular value decomposition. We'll just touch base with those, then you have to study it. It's a self-study. So couple differential equation. Also here we touch some base with multivariate calculus. So if we have the differential equation for dx as a vector over dt, then it will equal m dot product with x plus the I vector. Calculate the eigenvectors and eigenvalues. Eigen have a typical form of lambda equal lambda r plus lambda I to the power j, where I is the square root of -1. The corresponding eigenvector it could be like a MATLAB code as a PDF or just handwritten. Just you can handwritten it, picture it, and submit as PDF. Is that okay? You are welcome. So the corresponding eigenvector component has dynamics of e to the power lambda t equal e to the power lambda rt, and these are things which is if it's less than 0, it's stable. If it's greater than 0, it would be unstable. So all these comments you have to revise it and dig more on it. Practical program for approaching equation coupled through a term. Mx, step 1, find the eigenvalues and eigenvector of M. Step 2, decompose x into eigenvector component. Stretch scale each eigenvalue component. Solve for C and transform back to original coordinates. Egm, this is the command in MATLAB. Here are the explanation of each step. Putting all together, it will be like this one. Left eigenvector, putting all together again. Then we have the trace and determinant. This is the equation of determinant. Special matrices, normal matrices. This is how we do the transpose. And you know the transpose, what is the transpose? We have this E, and here is the transpose. We make each column to be, first column to be the first row, second column to be the second row, third column to be the third row, and we need this a lot in the machine learning. So transpose concept is known. So eigenvector decomposition in this case, how it will be, then we do the transpose Just give me a sec. So here we do the transpose. So we'll take the first column to be the first row, second column to be the second row, nth column to be the nth row. Left and right eigenvector are identical. Special matrices, if we have S transpose equal S. Covariance matrices, Hopfield network properties, eigenvalues are real, eigenvectors are orthogonal. So it is a normal matrices. So if we do the transpose, it will be the same again. So SVD decomposes matrices into outer products of neural spatial mode and temporal mode. So if we have the matrix M n by T, this is T1, T2, T3 till T equal T, and we have N1 by rows, N2 and row. So this would be M11, M12, M1T till NT. So how we do this? So we have columns of U are eigenvector of MM transpose, and then we'll have rows of V transpose are eigenvector of M transpose M, and this thus the SVD pairs the spatial patterns with associated temporal profiles through the outer loop. This is how it will become, and here is the end. So guys, this is like a quick, this is a quick revision of linear algebra. You need to dig more. I'll give you an extra time today to use this time to study more. Go through YouTube. If you find anything difficult, ask me for a resource for that topic through email. But now, guys, we need to talk about project topics. What I expect from you for the project, because I need to give you the full term time to work with the project. That's why we need to finalize this week. So who, for example, has an idea for the project? So because the project topic should be, okay, great. We have here 1, 2, 3, almost 4 groups. Do we have individuals? We have 1. Okay. So for those group, do you have something in mind as a topic? Like Chandel, group number 2? Unmute your mic and start saying, what do you think? Because the remaining of the session will make it like a brainstorming about the project. Go ahead. Mr. Chandel, unmute your mic and go ahead. Okay, you don't have a topic yet. Who think about a topic? Who think about the topic? It's just a brainstorming, guys. Nothing would be recorded about your project. So you can change your topic till next week. So because once we finalize, then next week we should assign the topic. Okay, I'll give you some guidance how to start working in your project. I believe this would be better for you. So the project you should search, you have 2 options. First option, to find a research paper, a recent research paper that published in a journal or a conference. and reproduce the work. What is your contribution? Your contribution, you should add something to improve the result of that paper. Is option 1 is clear? I will write all of those in a document and put it in the resources, or what's called project instruction or a project guide. So you will search, you and your group, for a recent published paper in a conference or in a journal, whatever. Either in anomaly detection, any field you find, using machine learning techniques. You will reproduce this paper, you will repeat the work, and you will do something extra to improve the results. Is this clear, the first way or the first direction of the project? Yes, no? Okay, thank you guys, thank you. The second way is to find a recent published data set, for anomaly, for IoT, for industrial IoT, for mechanical, for civil, whatever you want, for robots, whatever, computer vision, whatever. Then you would like inform me in a couple of lines what you will do with this data set. You should do a certain machine learning technique, what your problem you are trying to solve using this data set. The only one constraint, for example, if you choose to pick up a data set, there should be 2 data sets in order to generalize your work. So you should apply the techniques that you will use in both data sets, and you can compare the results. But if you choose a paper, if they use 1 data set, most of the paper they use more than 1 data set, published paper. And from now, if you choose the security and anomaly detection, don't go to NSL or KDD. It's outdated data set. I need a recent data set. There is a lot published data sets on the field you choose. Then we can agree. You give me what is in your mind, then I can give you some guidance, and we agreed in the topic and assigned to your group. Questions about this? Is it clear? And the one constraint, I need the work to be original, no copy and paste. Plagiarism detector will be used, like Turnitin. Code similarity check will be used. So I need the work to be original, your group work, guys. Okay. So about choosing the project topic, I think these are clear now. I will put everything together next week or this week in order to think about the topic. So by next Tuesday, the group will be finalized and announced. Then by Friday, all topics should be approved in order, guys, to have time for you June and July to work in the project. Second point, group presentation. Then there is a progress report. I will assign the date next week for it. Then I will publish the course plan. There is a progress report. Then another component is the delivering the group presentation. So your group presentation, each member of the attendance is mandatory in person during those weeks. The TA will be with you. Then the group will make like a laptop with a Zoom link send me an invitation using Zoom link with a camera so I can attend the presentation also. And the TA will be with you in the classroom. The thing, for example, group number 2, you are 5 now. These 5 students, each student will present. We'll put the presentation, timing, what time for the presentation, how many minutes for the questions. All of those would be clear for everybody. Maybe in 2 weeks' time, once we finalize topics and everything. And when is your presentation date? Attendance is mandatory for all class in person. Attendance will be taken. And please don't do your presentation and leave the class. No, you have to attend all the presentations. This is, you will get benefit from your colleagues. You will get a new knowledge from different project topics. And also it's a kind of respect. Since they attend your presentation, you have to attend theirs. Correct? So it's a kind of respect. And I'm trying like to give you some how things are going in real world or in a professional career. If you are in a company, if you are with a group, if you are in a team, if you are doing like a conference, if you are whatever you choose your career path. So attendance is mandatory. Attendance will be taken. I believe we need maximum 2 days for a presentation, or 1 day would be enough for all groups. And it will be the last class before the final exam. It will be the last class before the final exam. Now, in the presentation, you are a group of 5. For example, we have Chandan, Gurpreet, Zishan, Jen Ming, and Han Kumju. Those are a group. If I ask like Chandan a question that was presented in Han Kunju part, said, oh, this is the part of Han Kunju, I cannot answer, let's Han Kunju. No. Each group member should be aware about everything. Okay, I know that you'll distribute the work, but once you bring things together, you should be aware about each step taken in that project, either in code or in written. Is that clear? Yes, no? Thank you, Ruping. Thank you, Shuming. Thank you, Hankon. So it's clear. Another thing, for a group project, code, presentation, final report should be submitted only by 1 member. So each group should choose 1 member that will be submission. So 1 submission per group would be. Multi-submission, last year, some MEng student, they are in a group in the, which course was it? Programming for Engineers, 9013. So multiple members submit different version. No, 1 guy, he's a coordinator. He finalize everything, then he will be responsible for the submission. So 1 submission per group, because multiple submission with sometimes different. I will allow resubmission. So if you like, after you submit, then the group, hey, we forget to put this, we forget to do that, you can resubmit, but not after the deadline. Clear? Yes, no? Thank you, Yungbun. So, is everything about the project now is clear? Any question till here? I'll put everything together. Even the project format, the progress report format, what is the type of font, how is the font size, what is the format to be followed, which is IEEE format, what is the citation. Citation is very important also. even images, if you use a ready-made images or an image in a paper or in a website, you should cite it properly. So you are a graduate student now, so citation is very important. And the citation format is IEEE format, and the paper format would be, or the final report format, it would be like an IEEE paper. And this is also a way to teach you how to work on a template. So the template would be also available in the resources, the paper template, the report template, the IEEE template. I will add it to the resources. Any question by any group? Anything in your mind? No questions? Okay, final exam. It's most probably would be on, this is approximate date, but I will try to stick with it. It would be Tuesday, August 9, and I will make it from 8:30 to 11:30, or we might make it from 9 to 12. It would be in person, in campus, closed book exam. It will be consisting of multiple choice, some problem solving in machine learning, things that we'll go through the course. So these are most of the thing about the course. Next class would be the probability and the optimization review. We might like dig more in optimization. Then the next, we'll start with the classification and we go through machine learning techniques. Question, comments? Please.
Hey, Muhammad Noor, can you hear me?
Yeah, Afshan. Yeah, Afshan. This is Afshan, our great TA in this course. Go ahead, Afshan.
I just wanted to mention 2 points. First, please note that you go with the first option, meaning reproducing a published paper. It cannot be your own paper. The second,
yes, of course. Yes, thank you for this. Thank you.
The second is it cannot be a project already done in the previous semester. So that bottom line is that you cannot get twofold credit for the same work.
Yes, that's it. Guys, maybe thank you, Afshan, for clarifying this and bringing this in. When I said that plagiarism detector Turnitin would be used, so don't take like previous work from previous terms, because this course have been offered even in another university, will catch you. So this what I meant by I need your work to be original. And if you publish a paper, you cannot reproduce your same paper. Thank you, Afshan, for bringing this in. So guys, we're trying, myself, the TA, and the university overall and the department, to get a high quality work from you guys. This, not to make things complicated to you as a students. No, we're trying to teach you. We need your hands to be dirty, to dig in machine learning and work closely and to understand. Because, you know, even if I explain in this, what I explained today, or even if I explained linear algebra in deep, as that you never know about linear algebra and I explain everything to you. If you depend only in my presentation or in my lecture or in with the meeting with me during office hour or with the TA, after 2-3 days you will forget what we said. But once you work practical, or how they call it, get your hand dirty in the job, you will learn and you will never forget. And when I ask you why you use like SVM with Gaussian kernel, not linear kernel. Then you will answer, oh, when we did the data pre-processing and we visualize our data, it's shown clearly with the data visualization that the data are non-linear. So due to non-linearity of the data, we don't use linear kernel. Did you get my point? Once you work by yourself and as a group, explain each thing together, why use like SVM polynomial? Why you don't use, like, for example, naive Bayes? One of the technique we'll talk about it, which is Bayesian network or Bayesian machine learning based on the probability that we'll discuss next week. Why don't you use Bayesian network in this as one of the technique that you apply to your data? Then you'll tell me, oh, Bayesian assume that the data or the feature are distinct or independent from each other, which is not the case. Also, Bayesian model consider that the data are normally distributed, which is not the case when you draw the PDF of the data, probability density function. Based on this, we don't use naive Bayes. So I don't want you like try and error. I need you to understand, based on the nature of data on the given problem, these techniques are suitable. These parameter or hyperparameter tuning, if you choose to use optimization, those need to be optimized to get the best result, to maximize or to minimize the false alarm rate as a measurement, or to maximize the accuracy. What is your objective function in the optimization? These things we need you to know. And believe me, when you move to the work site, when you have these skills, you'll be fine. You'll find a very nice job. If you apply for any machine learning position, you'll be one of the first candidates that they will think to hire you. So this is for your benefit, not to make things complicated. I hope this is clear and clarify why in the department, Dr. Shami, who's the father of this course in Western engineering, he's the one who designed the course at the beginning and start offering it in 2018. This is the way and the philosophy of the department to have this course be taught in this way. We need you to understand what's going on, not a black box. As a machine learning, we know what goes in and what comes out, but we don't have to know what happened inside. No, our course, we need to know what happened inside and how we can fine-tune the thing to get a better result. Is that clear? And this is what I want from you guys in the project. I hope this clarify everything. If you have any question, if you have any comment option again, or any student have any question, anything, don't hesitate to say. We said this is a brainstorming about the project, how the course will be managed, how we'll go through the term. I promise you to give you some time to study the linear algebra by yourself, to revise, to recap what you studied in the high school and during the undergrad. And as I told you, if you find any topic, I can share with you a detailed presentation about that topic, also a detailed video about it. Questions? If you don't have any question, you are free to leave. See you next Tuesday with probability and optimization. Thank you all.